Good morning everybody, I am Sridharreddy. Today my topic is Dalton's law of partial pressure. So Dalton has given one law, that law is called the Dalton's law of partial pressure. So in order to explain this Dalton law of partial pressure definition, he taken one experiment and experiment is consisting of, he is taken a vessel of volume V, vessel is taken, volume of the vessel is V, and he filled with the N1 moles of the hydrogen. He filled with the vessel with the N1 moles of the hydrogen, and the pressure exerted by the hydrogen gas is taken as the P1, and he observed the pressure exerted by this hydrogen gas is the 0.3 atmosphere. Once again, he taken the vessel of volume V and he filled the vessel with the N1 moles of the hydrogen, and the pressure exerted by the gas of nothing but hydrogen is he observed as the 0.3, he given it as the P1. Now, same vessel, he replaced the N1 moles of the hydrogen with the N2 moles of the oxygen. Now he filled with the N2 moles of the oxygen in place of the N1 moles of the hydrogen. Simply we can say N1 moles of the hydrogen is replaced by the N2 moles of oxygen. Then pressure exerted by the oxygen, that is called as the N2 moles of the oxygen, which is given as the P2, and he observed the pressure exerted by the N2 moles of the oxygen, he observed as the 0.5 atmospheres. Now, third statement. Now he filled with the same vessel with the N1 moles of the hydrogen and N2 moles of the oxygen, or simply we can say N2 moles of oxygen which is present in the vessel is replaces with the N1 moles of the hydrogen and N2 moles of the oxygen, means that he filled with the mixture of the first two gases. Immediately he observed the pressure exerted by the mixture of the gas, pressure exerted by the mixture of the gas which is given as the P, and he observed this value is the 0.8 atmospheres. If you observe this relation, we can say 0.8 is equal to 0.5 plus 0.3. 0.8 is nothing but capital P, and 0.5 is nothing but P2, and 0.3 is called as the P1, nothing but P1 plus P2. So ultimately he observed a relation between these three phenomena. P is equal to P1 plus P2. What is the meaning of this one? Let us take it. The pressure exerted by the mixture of the gas. Pressure exerted by the mixture of the gas equal to sum of the individual pressures, and which is called as the Dalton's law of partial pressure. So what is the Dalton's law of partial pressure? The pressure exerted by the mixture of the gas equal to sum of the individual pressures, and each individual pressure is called as the partial pressure. Each individual pressure is called as the partial pressure. Now, I am taking the mathematical background, mathematical derivation of the Dalton's law of partial pressure. Now we have to calculate the partial pressure of the P1 and P2. Partial pressure of the each gas you have to calculate in terms of the total pressure. In terms of the total pressure. Same once again I am taking the same thing. I am taking a vessel is taken and which is filled with the N1 moles of the hydrogen, and the volume of the gas vessel is the V. The pressure exerted by the gas is P1. And number of moles is the N1. Number of moles is the N1. According to the ideal gas equation, so PV is equal to nRT, which is called as the ideal gas equation. According to the ideal gas equation, if you substitute in place of the P, P1, volume is the V, N is the N1, R and T are the constant. R is called as the universal gas constant, T absolute temperature, which is taken as the constant or which is taken at the given temperature. That's why the equation becomes as P1V is equal to N1 RT. Send the V that side. Ultimately you will get P1 which is equal to the N1 RT by V. Let us give equation number 1. Now same thing. Now N1 moles of hydrogen is replaced with the N2 moles of oxygen. Vessel is same, that's why volume will be the same. But the pressure exerted by the N2 moles of the oxygen. N2 moles of the oxygen. Pressure exerted by the gas is P2. Number of moles is N2. Volume is the V at given temperature. Ultimately, according to the ideal gas equation, PV, so P2V is equal to N2 RT. Send the V that side. P2 is equal to N2 RT by V. Let us give equation number 2. Now, third. What is the third is taken? Now the same vessel which is having the volume is V mixed with the, it is filled with the N1 moles of the hydrogen and the N2 moles of the oxygen. Nothing but we are taken the first two gases. Now, the pressure exerted by the mixture of the gas is taken as the P. P is this volume is consisting of the N1 moles of the hydrogen and N2 moles of oxygen. Total number of moles is N1 plus N2. Ultimately, according to the ideal gas equation, PV is equal to N1 plus N2 and RT, which is given as the PV is equal to nRT. The pressure exerted by the mixture of the gas, send the V that side. Ultimately, N1 plus N2 by into RT by V. Let us give equation number 3. So these are the 3 equations. Now, what is my aim? My aim is to calculate the P1 with respect to the total pressure, P2 with respect to the total pressure. P1 is called as the partial pressure of the first gas. P2 is called as the partial pressure of the second gas. P is called as the total pressure. So we have to calculate the partial pressure of the first gas with respect to the P. Nothing but you have to take the equation 1 divided by the 3. Then you will get the relation between the P1 and the P, and nothing but the relation between the partial pressure and the total pressure. So 1 divided by 3. 1 is nothing but this side P1 and this side will be the P, equal to this side N1 RT by V divided by total pressure is nothing but N1 plus N2 RT by V. So now you take P1 by P is equal to N1 RT by V. Here V by N1 plus N2 into RT. So RT get cancelled, V get cancelled. Ultimately you will get P1 by P is equal to N1 by N1 plus N2. Now send the P that side. Ultimately P1 is equal to N1 plus N1 by N1 plus N2 into total pressure. Now look at here. How to calculate the partial pressure? Partial pressure is equal to N1 by N1 plus N2. What is the N1 by N1 plus N2? Let us take it. Number of moles of the first gas to the total moles. Come on here once again. Partial pressure of the first gas equal to the number of moles of the first gas to the total moles, which is must be multiplied with the complete pressure. Nothing but it must be multiplied with the total pressure. Here N1 by N1 plus N2, which is given as the X1, where X1 is called as the mole fraction of the first gas. Mole fraction of the first gas. What is the mole fraction of the first gas? Number of the moles of the first gas by total moles, which is called as the mole fraction. Ultimately, in order to calculate the partial pressure, what we have to do? We have to multiply the total pressure with the mole fraction of the first gas. For example, here I will give you. In order to calculate the P2 value with respect to total pressure, what you have to divide? 2 divide with the 3. Ultimately, what you will get? P2 is equal to P2 nothing but here you will get N2 divided by N1 plus N2 into total pressure. Here N2 by N1 plus N2 is called as the number of moles of the second gas to the total number of the moles, which is called as the mole fraction of the second gas. Mole fraction of the second gas. Ultimately P2 is equal to X2 into P. X2 is called as the mole fraction of the second gas. What is the mole fraction of the second gas? Number of moles of second gas by total number of moles. How many gases you have taken? 2. If you are having the 3, then what is the Dalton's law of partial pressure? P is equal to P1 plus P2 plus P3. So what is the P1? P1 nothing but N1 by N1 plus N2 plus N3. 3 gases is there. What is the P2? P2 is equal to N2 by N1 plus N2 plus N3 into total pressure. If you calculate the P3, total gases are 3, then what is the P3? P3 is equal to N3 by N1 plus N2 plus N3 into total pressure. Nothing but the partial pressure of the third gas equal to the mole fraction of the third gas. What is the mole fraction? Number of moles of the third gas to the total number of the moles, and it must be multiplied with the total pressure, which is called the Dalton's law of partial pressure. Based on this one you will get the problems. Tomorrow I will give you the problems video. I will give you. Once again we will take Dalton's law of partial pressure. What is the Dalton's law of partial pressure? The pressure exerted by the mixture of the gas equal to the sum of the individual pressures. Each individual pressure is called the partial pressure. If the 2 gases are there, P is equal to P1 plus P2. If the 3 gases are there, P is equal to P1 plus P2 plus P3. How to calculate the P1? P1 is equal to N1 by N1 plus N2 into total pressure. 2 gases are there. If the 3 gases are there, P1 is equal to N1 by N1 plus N2 plus N3 into total pressure. Nothing but P1 partial pressure of the first gas equal to number of moles of the first gas to the total number of the moles into P. Similarly, P2 is equal to N2 by N1 plus N2 plus N3 if the three gases. P3 is equal to N3 by N1 plus N2 plus N3 into the total pressure. By using this one, we will predict the partial pressure of the each gases, and the Dalton's law of partial pressure says that the pressure exerted by the mixture of the gas equal to sum of the individual pressures. Each individual pressure is called the partial pressure. P is equal to P1 plus P2 for the two gases. P is equal to P1 plus P2 plus P3 for the three gases. What is the P1? P1 is equal to N1 by N1 plus N2 into total pressure for the two gases. For the three gases, P1 is equal to N1 by N1 plus N2 plus N3 into total pressure, where N1 is called as the number of moles of the first gas to the total number of the moles. Tomorrow we will discuss the problem. Thank you.